Dear students, in the previous video, we discussed about the left hand limit. In this video, we will discuss about the right hand limit. So we considered the function fx equals x square minus 1 over x minus 1, and we saw that at x equal to 1 the function is not defined, and then we were checking that what is happening near x equal to 1. So what we did in the previous video when we were discussing the left hand limit, we took points near 1. We started from 0.9 and slowly we moved towards 1 from the left side. Now what we will do, we will consider points near 1. Suppose we consider 1.1, and from 1.1 slowly we will move towards 1. If you observe, now we are moving towards 1 from the right side. So again, let us make a table to understand it better. X, fx, let's start from the right side just to observe it in a simpler manner. Let's take x equal to 1.1. At 1.1 the value of fx will be 2.1. Let's move towards 1. Let us take a value which is more closer to 1. Let us take 1.01. At 1.01 the value of fx will be 2.01. Again, let us take a value which is more close to 1. Let's say 1.001. At 1.001 the value of fx will be 2.001. Again, let us take a value which is more closer to 1. Let's say 1.0001. At this point the value of fx will be 2.0001, and like this we are moving towards 1 from the right side. Again, if we observe this table properly, we can say that as we are moving towards 1, the value of the function is again moving towards 2, and hence we can write that limit of the function fx as x tends to 1 from the right side. So we will put a small plus here. This is equal to 2. What is the meaning? That as x approaches 1 from the right side, the value of the function fx approaches 2. So what we observed so far, limit of the function fx as x tends to 1 from the left side, this was equal to 2. Let us revise the meaning. The meaning is, as x approaches 1 from the left side, the value of the function fx will approach 2. This limit was called as left hand limit. The other thing which we discussed was limit of the function fx as x tends to 1 from the right side. This is again equal to 2. What is the meaning? The meaning is, as x approaches 1 from the right side, the values of the function fx approaches 2. This limit is called as right hand limit. One more thing which I would like to emphasize here, a very important point, is that when you are saying x tends or approaches 1 from the left side, be careful that this small minus sign is only denoting that you are moving towards 1 from the left side. It does not mean that you are taking negative values. It only means that you are moving towards 1 from the left side. Same way, when we are writing x tends to or approaches 1 from the right side, this small plus here, it denotes that you are moving towards 1 from the right side. It does not mean that you are taking positive values. No, it doesn't mean that. It simply means that we are moving towards 1 from the right side. Now let us write generally about limit. Suppose limit as x tends to a from the left side of the function fx is equal to L. L is a number. Okay. What is the meaning? The meaning is that as x approaches 1 from the left side, in that case, the value of the function fx will approach L. This limit is called as left hand limit. Same way, if limit of the function fx as x tends to a from the right side, suppose this is equal to L, where L is a number. This means as x tends to a from the right side, in that case the values of the function fx will approach L. This is known as right hand limit. Let us discuss about the existence of limit. Suppose left hand limit is equal to right hand limit. In this case, we say that the limit exists. If the right hand limit and the left hand limit are not equal, we will say that the limit does not exist. That also let us write. I will write in short now. LHL, left hand limit. If this is not equal to RHL, right hand limit, in this case we say that limit does not exist. Let us write mathematically. Suppose limit of the function fx as x tends to a from the left is equal to L, and the limit of the function fx as x tends to a from the right, this is also equal to L. So what we have written? We have written that the left hand limit is equal to the right hand limit. It means that limit exists. So we can write this implies limit exists. In this case, we write as limit of the function fx as x tends to a. No need to write from left or from right. This is equal to L.